When you're responsible for running the CNC router in the shop, how do you know what RPM and feed rate to run? And where do you go to find such information? Let's answer that question. It's bit time.
Quick bits of information. Eli the bit guy.
When you're the one operating the CNC router and you're responsible for getting parts produced, two important issues must be addressed right up front: the quality requirements of the finished part, and how fast can I get the job completed. For dependable, consistent results, you need to begin with solid application data, and the AmericanBitWorks.com website is a great place to find it. From the homepage, simply click on the Application Data button. Here you'll find the needed details for a variety of bit styles. Simply scroll down the page to find the style you're using. For example, let's say you're using a general purpose single flute upcut. Here you see a picture of the end of the bit and the side view, followed by general information about this bit style. We consider this design to be the first choice for general purpose applications. Next, you'll see a table of RPM, bit diameters, and chip loads. It's important to note, these tables provide a starting point, which is important when you're just getting started. Later, we will address variations from the basic starting parameters, but for now, let's focus on getting started. Across the top, we have RPM, the diameter of the bits from small to large, and chip load by diameter. Let's practice with a couple examples. Say you're using an 1/8 inch diameter bit in soft plastic. Your RPM would be 24,000, and your chip load would range from 4 to 6 thousandths based on running a depth of cut of 1 times diameter or less. If you were using a 1/4 inch bit in soft plastic, your RPM would be 18,000 and your chip load would range from 8 to 12 thousandths when running a depth of cut of 1 times diameter or less. If you were running the same 1/4 inch bit in aluminum sheet, your RPM would still be 18,000 and your chip load would range from 2 to 4 thousandths. Now, if by chance you're not familiar with the term chip load, no worries. Chip load is simply the distance your bit feeds per tooth each time it turns 1 revolution. Chip load is the information we use to determine feed rate, which is commonly referred to as inches per minute. We use this simple formula to determine inches per minute: RPM times the number of teeth, which can also be referred to as cutting edges, times chip load. Let's use the 1/4 inch diameter in soft plastic for example. Now let's see how it looks on the whiteboard. 18,000 RPM times 8 thousandths times the number of teeth. And since this is a single flute bit, that number would be 1. This results in a feed rate of 144 inches per minute. We show this formula expressed in 2 different ways, so simply use the one you're most comfortable with. Let's do one more example. This time, we'll use the 12,000th chip load. 18,000 RPM times 12 thousandths times the number of teeth equals 216 inches per minute. I hope these examples have helped to clear up any questions you may have had regarding calculating feed rates. A question we often hear is, can I feed slower or faster than what the chart shows? Yes, you can. Just remember these quick bits of information. If you feed too slow, watch closely for chip melting because you don't want that. And if you want to feed faster, be sure your work holding is secure. And be aware that feeding faster will affect the finish on the surface you produce. We address these issues more closely in some of our other videos. Also, for clarity, the formula for determining feed rate in inches per minute remains the same no matter what style bit you're using. In the application notes, you'll find additional helpful details. For example, if you're cutting small parts, typically something smaller than 2 inches, your CNC machine may not be able to reach the programmed feed rate in such a short distance. This is because machines need a little distance to accelerate and to decelerate before changing direction, If you find your chip load is too light on small parts, simply reduce the RPM, which will create an increase in the chip load. Also, if you need to make cuts deeper than 1 times the diameter, pay attention to the recommended reductions to chip load. It's important to realize the application notes vary between bit designs, so pay close attention when you scroll through the different bit styles. We hope that you find the application data tables helpful and easy to use. I'm Eli the Bit Guy, and this has been
Quick bits of information. Eli the bit guy.